Hi, in this particular part of our lecture series on K-means clustering, this is our third part. We saw in the last lecture and we saw one example where we generated random numbers, random data, and we created four different centroids and four clusters. So now in this particular example, we will work ahead, right? So now we go through one more example using historical data set. The data set which I am going to use for this particular example contain more than 34,000 records which contain attributes like customer age, total years employed, income, debit card information, other debit information, whether the client is defaulter or not, client's address, and ratio between client's debit and income. It contains more than 34,000 records and medium-sized dataset in volume. Our task is to group the customers based on their similar characteristics. This is a business problem where we wish to know which customer are reliable and having good financial track record. For example, customers with high profit and low risk, or customers who are risky and are not reliable. This clustering can be useful in many ways in different business applications, like knowing the potential customers, which customer to retain, which customers can be targeted for business strategies and marketing. The dataset is downloaded from the IBM object storage, and I acknowledge IBM for this dataset. I have downloaded the dataset using wget command as shown here. If like this particular dataset is a CSV file containing 34,276 records. Since we have downloaded the CSV file, let us load the CSV file now. First step is we import Pandas, as we need to download the particular data set in data frame. I just wish to remind you that apart from importing Pandas, we also need different other libraries too. As seen in our last example, we have already imported NumPy, Matplotlib, and sklearn. We have made Matplotlib inline since we will have visual display, that means plotting the current code output, as you can see here. We will perform some pre-processing of dataset before we go ahead, as one of the attribute is address, which is categorical type, as we cannot apply dissimilarity matrix on categorical data like Euclidean distance function. Hence, for this particular problem, we will drop this feature. As shown in code line number 8, we are removing the address attribute. Now, our next step, we will normalize our data set. Why normalization? And how to normalize is our obvious question. Well, normalization is essential to bring all attributes or features having different magnitude and having different distribution on common platform. For this purpose, we will use standard scalar method. This function is part of pre-processing module of sklearn library. So we will have data frame accept first attribute, which is id in x, as shown in line number 11. This, as shown in line 12, we remove all null values records, and then using the standard scalar function, we will transform the data set and normalize it as shown in code line number 13, and store in array class underscore data set. And finally, as shown in line number 14, we will display the array class underscore data set. The output you can view on the screen. Now, next step is to set the model and fit the model. We start with k value equal to 3, that means initialize k as 3. As shown in code line number 15, next step is we set the model by passing 3 parameters. These 3 parameters are shown in line 15. including initialize with k-means plus plus, which is the method to obtain dissimilarity distance measurement. Total cluster numbers initialized are 3 and total iterations to obtain new centroid are 12. Next, as shown in line code 17, we fit the model. Next, we will label it. Hence, the data points will be labeled as part of clusters as 0 or 1 or 2. And finally, we will display it as shown in code line number 19. Now, we will insert this label attribute in the data set. We assign the value of labels to the attribute class underscore KAM, which will be the part of data frame as shown in the line 20. And finally, we check the first 5 records of data frame using df.head function. Okay, so now next part is we'll also obtain the centroid value by averaging the features in each cluster using the group by function. It group the class underscore km and then obtain mean of it as shown in code line number 22. Basically class underscore km is cluster of k-means. Is a short form that we are using as attribute. Okay, now finally we plot the cluster using scatter plot. The data distribution plotted using scatter plot for the age and income attribute of dataset as shown in code line number 23 to 26 over here. Using show function, we display the plot. You can see the plot, the scatter plot, which is very much visible against age in x-axis and income as a y-axis. Finally, let us display 3 clusters obtained for attribute education, age, and income as 3D scatter plot. In previous slide, we saw that we plotted two-dimensional plot over here against income and age, and now let us plot three-dimensional scatter plot. Code is very simple and easy to understand for this purpose. We use Matplotlib's toolkit library and import axis 3D module. We specify the plot size using fixed size attribute as 9 and 8 as width and height for the figure function. Then we create the AX object using axis 3D function and pass appropriate parameters like elevation value as 50. Finally, we plot the 3D scatter plot and assign age, income, and education as x, y, and z-axis labels respectively. Here, K-means clustering algorithm partition customers' dataset into mutually exclusive groups. In this particular example, we have created 3 clusters. The cluster form for the customers are grouped based on their similar characteristics considering their age, income, and education. We can term them as 3 clusters grouped as good education and old-aged customers, middle-aged with middle income and middle education, and finally young-aged with low income and less education. Okay, so here we conclude K-means algorithm, and you can see the plot that we have created in 3-dimensional against income, age, and education attribute. I wish that you go through the first lecture in process to understand the concept of K-means algorithm and then understand and execute the codes as described in the previous lecture, that is part 2, and in this particular lecture, that is part 3. You can pause the lecture and work on it. I execute this Python course using Jupyter Notebook. Thanks for being with me in this lecture. We will meet again with a new lecture on new topic. Until then, I sign off with all of my wishes for you. Learn, share, and grow. Have a great day.